It goes without saying the most Earth-like planet we know of is Earth. Barring a scenario where many Earths exist within a hypothetical multiverse, this is the only one we've got. The qualities that make our planet Earth-like, its rockiness and mass among others, are important to researchers searching for other worlds like ours. Other galaxies could be full of sibling Earths. In fact, evidence suggests there may be as many as one Earth-like planet for every 5 Sun-like stars in the Milky Way alone. Earth is our home, which makes it special in its own right. But there could be countless more like it waiting to be found or even born. The ongoing hunt for Earth-like worlds, especially over the next few decades, hopes to illuminate how ordinary and extraordinary our planet may be. What is an Earth-like world? Though there are some basic requirements for a world to be considered Earth-like, overall, it's difficult to narrow down a definition. We know that mass is key when it comes to identifying Earth-like worlds. Some research suggests that objects just 1.6 times the size of Earth are more likely to be gaseous, making them less similar to our planet. Usually we categorize planets by how massive they are. Caitlin Rasmussen, an astrophysicist at the University of Michigan, told the Planetary Society. There's no category below Earth, so even if there's something Mercury size, we would still call that an Earth. Mass is critical to spotting worlds like ours, but there are other factors to consider, such as a star's habitable zone. The not too hot, not too cold region where liquid water can exist on a planet's surface. That's where things get a little more nuanced. I think it's a spectrum, said astrophysicist Moya McTire, who completed her doctoral thesis in exoplanet habitability. There are points you can pass to make a planet more Earth-like, and I'd say mass or radius are some of the benchmarks. Being in the habitable zone of a star is also important. The world should be able to host water and have an atmosphere, not as thin as Mars, but not a puffy, Neptune-like atmosphere. Even with those guidelines, there's a gray area. For example, some researchers would argue that a planet can't be Earth-like unless it orbits around a sun similar to ours, that is, a G-type main sequence star. Unpacking what it truly means to be Earth-like evokes a host of scientific and philosophical questions. Although defining that term is pretty complicated, there are some worlds that appear to fit the description, or at the very least, parts of it. Earth-like worlds of interest. The first exoplanets, worlds orbiting stars besides our own, were discovered in the 1990s. In the grand scheme of, well, everything, that's very recent. It's impressive how much scientists have been able to uncover about these distant worlds in such a short time. With the help of ground and space-based telescopes, researchers have found about 4,000 confirmed exoplanets and thousands of other candidates. A relatively small number of these worlds bear similarities to Earth. The future of Earth-like world searching. To better predict the habitability of Earth-like worlds, exoplanet researchers need to understand the atmospheres around them. That takes some seriously powerful tools, and thankfully, they're coming soon. In 10 years, we're going to have ridiculously good telescopes, Rasmussen said. They're going to be like 30 meters across, 40 meters across, whereas the largest we have right now is about 10 meters across. NASA's Roman Space Telescope, set to launch sometime in the mid-2020s, is one such telescope. It'll embark on a 5-year journey to identify 2,500 new exoplanets. Launching even sooner than that is NASA's James Webb Space Telescope, JWST, which is poised to be one of the most powerful exoplanet hunters ever. A significant, explicit part of its mission is to study the atmosphere around Earth-like worlds. Plus, it'll search for biosignatures, gases associated with past or present life. There's something deeply humbling in looking to far-flung worlds for something shared with our own. It takes a lot of precise circumstances for a planet like ours to exist. The idea that this exactness could repeat itself doesn't subtract from how special Earth is. It amplifies the possibility that life can thrive somewhere else. It's an honor to be this common. The 10 most Earth-like exoplanets. Scientists have found over 4,000 exoplanets since the first such world was confirmed orbiting a Sun-like star in 1995, according to NASA's Exoplanet Exploration page. More than half of these discoveries were made by NASA's Kepler Space Telescope, which launched in 2009 on a mission to determine how common Earth-like planets are throughout the Milky Way galaxy. Discovering the first true, alien Earth is a long-held dream of astronomers, and recent exoplanet discoveries have shown that small, rocky worlds like our own are abundant in the galaxy. To qualify as potentially life-friendly, a planet must be relatively small, and therefore rocky, and orbit in the habitable zone of its star, which is loosely defined as a location where water can exist in liquid form on a world's surface. When telescope technology improves, other factors will be considered as well, such as the planet's atmospheric composition and how active its parent star is. 1. Gliese 667 cc. This exoplanet, which lies just 22 light-years from Earth, is at least 4.5 times as massive as Earth, according to NASA's Jet Propulsion Laboratory. Opens in new tab. Gliese 667 cc completes one orbit around its host star in a mere 28 days, but that star is a red dwarf considerably cooler than the Sun, so the exoplanet is thought to lie in the habitable zone. However, Gliese 667 cc, which was discovered with the European Southern Observatory's 3.6-meter telescope in Chile, may orbit close enough in to be baked by flares from the red dwarf. 2. Kepler-22b. Kepler-22b lies 600 light-years away. It was the first Kepler planet found in the habitable zone of its parent star, but the world is considerably larger than Earth, about 2.4 times our planet's size. It's unclear if this super-Earth planet is rocky, liquid or gaseous. Kepler-22b's orbit of 290 days is pretty similar to Earth's 365, Space.com previously reported. The exoplanet orbits a G-class star like our Sun, but this star is smaller and colder than Earth's. 3. Kepler-69c. Kepler-69c, which is about 2,700 light-years away, is about 70% larger than Earth. So, once again, researchers are unsure about its composition. The planet completes one orbit every 242 days, making its position within its solar system comparable to that of Venus within ours. However, Kepler-69c's host star is about 80% as luminous as the Sun, so the planet appears to be in the habitable zone. 4. Kepler-62f. This planet is about 40% larger than Earth and orbits a star much cooler than our Sun, according to NASA. Its 267-day orbit, however, puts Kepler-62f squarely within the habitable zone. While Kepler-62 orbits closer to its red dwarf star than Earth does to the Sun, the star produces much less light. Kepler-62f lies about 1,200 light-years away and, due to its large size, is within the range of potentially rocky planets that may hold oceans. 5. Kepler-186f. This planet is at most 10% larger than Earth, and it also appears to reside in the habitable zone of its star, though on the zone's outer edge. Kepler-186f receives just one-third of the energy from its star that Earth gets from the Sun. Kepler-186f's parent star is a red dwarf, so the alien world is not a true Earth twin. The planet lies about 500 light-years from Earth. 6. Kepler-442b. This exoplanet is 33% larger than Earth and completes an orbit of its star every 112 days, according to NASA. Opens in new tab. The discovery of Kepler-442, situated 1,194 light-years away from Earth, was announced in 2015. One study, published in the monthly notices of the Royal Astronomical Society, opens in new tab, in 2021, found that this exoplanet may receive enough light to sustain a large biosphere. The researchers analyzed the likelihood of different planets to be able to carry out photosynthesis. They found that Kepler-442b receives sufficient radiation from its star. 7. Kepler-452b. This world, whose discovery was announced in 2015, is the first near-Earth-size planet that orbits around a star the size of the Sun, according to NASA. Opens in new tab. Kepler-452b is 60% larger than Earth and its parent star, Kepler-452, is 10% larger than the Sun. Kepler 452 is very similar to our Sun, and the exoplanet orbits in the habitable zone. At 1.6 times the size of Earth, Kepler 452b has a better-than-even chance of being rocky, its discoverers have said. Kepler 452b resides 1,400 light-years from Earth. It takes Kepler 452b just 20 days longer to orbit its star than Earth does. 8. KEPLER 1649c. When the data from NASA's Kepler Space Telescope was reanalyzed, scientists discovered Kepler 1649c. The exoplanet was found to be similar in size to Earth and orbiting in its star's habitable zone. During the initial data collection from the telescope, a computer algorithm misidentified the astronomical body, according to NASA, opens in new tab, but in 2020 it was discovered to be a planet. Kepler 1649c is located 300 light-years from Earth and is only 1.06 times larger than it. When comparing the light that the two planets receive from their stars, scientists found that this exoplanet receives 75% of the light Earth does from the Sun. 9. Proxima Centauri b. Proxima Centauri b is located just 4 light-years away from Earth, making it Earth's closest known exoplanet, according to NASA Exoplanet Exploration. The exoplanet, which was discovered in 2016, has a mass that is 1.27 times that of Earth's. Although the exoplanet can be found in the habitable zone of its star, Proxima Centauri, it is exposed to extreme ultraviolet radiation. This is because it lies very close to its parent star and has an orbital period of just 11.2 days. 10. TRAPPIST-1e. Orbiting the star TRAPPIST-1 are the most Earth-sized planets ever discovered in the habitable zone of a single star. This planetary system is made up of 7 worlds. Water on most of these planets are likely to have evaporated early in the system's formation, Space.com previously reported. However, a 2018 study found that some of these planets could hold more water than Earth's oceans. One of the worlds, called TRAPPIST-1e, is thought to be the most likely to support life as we know it. The search for life beyond Earth is really just getting started, but science has an encouraging early answer. There are plenty of planets in the galaxy, many with similarities to our own. But what we don't know fills volumes. Observations from the ground and from space have confirmed thousands of planets beyond our solar system. Our galaxy likely holds trillions. But so far, we have no evidence of life beyond Earth. Is life in the cosmos easily begun and commonplace? Or is it incredibly rare? There are 5,322 confirmed exoplanet till date. 9414 planets are in NASA's candidate, and from them 3,989 planets are in planetary system. An exoplanet or extrasolar planet is a planet outside the solar system. Latest exoplanet. Planet name: KMT 2021 BLG 1105 LB. Planet type: gas giant. Detection method: microlensing. 1835 Neptune-like. 1679 gas giant. 1608 super-Earth. 195 terrestrial. 5 unknown. By method: 74.8% transit, 19.4% radial velocity, 3.4% microlensing, 1.2% imaging. But not all of them are in habitable zone. What is the habitable zone? The definition of habitable zone is the distance from a star at which liquid water could exist on orbiting planets' surfaces. Habitable zones are also known as Goldilocks zones, where conditions might be just right, neither too hot nor too cold, for life. When searching for possibly habitable exoplanets, it helps to start with worlds similar to our own. But what does "similar" mean? Many rocky planets have been detected in Earth's size range, a point in favor of possible life. Based on what we've observed in our own solar system, Large, gaseous worlds like Jupiter seem far less likely to offer habitable conditions. But most of these Earth-sized worlds have been detected orbiting red dwarf stars. Earth-sized planets in wide orbits around Sun-like stars are much harder to detect. And, of course, when talking about habitable exoplanets, we're really talking about their stars, the dominant force in any planetary system. Habitable zones potentially capable of hosting life-bearing planets are wider for hotter stars. Smaller, dimmer red dwarfs, the most common type in our Milky Way galaxy, have much tighter habitable zones as in the TRAPPIST-1 system. Planets in a red dwarf's comparatively narrow habitable zone, which is very close to the star, are exposed to extreme levels of X-ray and ultraviolet, UV, radiation, which can be up to hundreds of thousands of times more intense than what Earth receives from the Sun. When searching for possibly habitable exoplanets, it helps to start with worlds similar to our own. But what does "similar" mean? Many rocky planets have been detected in Earth's size range, a point in favor of possible life. Based on what we've observed in our own solar system, large, gaseous worlds like Jupiter seem far less likely to offer habitable conditions. But most of these Earth-sized worlds have been detected orbiting red dwarf stars. Earth-sized planets in wide orbits around Sun-like stars are much harder to detect. And, of course, when talking about habitable exoplanets, we're really talking about their stars, the dominant force in any planetary system. Habitable zones potentially capable of hosting life-bearing planets are wider for hotter stars. Smaller, dimmer red dwarfs, the most common type in our Milky Way galaxy, have much tighter habitable zones as in the TRAPPIST-1 system. Planets in a red dwarf's comparatively narrow habitable zone, which is very close to the star, are exposed to extreme levels of X-ray and ultraviolet, UV, radiation, which can be up to hundreds of thousands of times more intense than what Earth receives from the Sun. Stars slightly cooler and less luminous than our Sun, called orange dwarfs, are considered by some scientists as potentially better for advanced life. They can burn steadily for tens of billions of years. This opens up a vast timescape for biological evolution to pursue an infinity of experiments for yielding robust life forms. And, for every star like our Sun, there are 3 times as many orange dwarfs in the Milky Way. K-dwarfs are the true Goldilocks stars, said Edward Guinan of Villanova University, Villanova, Pennsylvania. K-dwarf stars are in the sweet spot, with properties intermediate between the rarer, more luminous, but shorter-lived solar-type stars, G-stars, and the more numerous red dwarf stars, M-stars. The K-stars, especially the warmer ones, have the best of all worlds. If you are looking for planets with habitability, the abundance of K-stars pump up your chances of finding life. Exoplanet temperature, size, star type. The galaxy offers up a menu of worlds that echo aspects of our own, yet at the same time are vastly different.